Hi stats students, in this video I'm going to show you how you can use SPSS to perform an analysis of variance and then also perform a post hoc test as well. To begin with, the problem that I am concerned with is stated on page 319, and it has to do with a social psychologist who is studying the influence of knowledge of previous criminal records on juries' perceptions of the guilt or innocence of defendants. The researcher recruits 15 volunteers who have been selected for jury duty but have not yet served on a trial. The researcher shows them a video of a 4-hour trial in which a woman is accused of passing bad checks. Before viewing the tape, however, all of the research participants are given a background sheet with age, marital status, education, and other such information about the accused woman. The sheet is the same for all 15 participants with one difference. For 5 of the participants, the last section of the sheet says that the woman has been convicted several times before of passing bad checks. So we'll call those participants the criminal record group. For 5 other participants, the last section of the sheet says that the woman has a completely clean criminal record, the clean record group. And then for the remaining 5 participants, the sheet does not mention anything about criminal record one way or the other. So they're the no information group. And so I've used the numbers 1 to represent my criminal record group, 2 to represent the clean, and then 3 to represent the no information group. So the participants are randomly assigned to the groups, and after viewing the tape of the trial, all 15 participants make a rating on a 10-point scale, which runs from completely sure she is innocent, which would be 1, to completely sure that she is guilty, which is 10. The results of the fictional table were shown at the top of page 320, but we're not interested in that since we're going to be using SPSS. So what I'm going to do is I'm going to go to Analyze and then go down to compare means, and then to one-way ANOVA. And then I'm going to do 2 things. First off, I'm going to have my group be my factor because that's how I'm grouping them nominally. Group was a nominal data there. And then my dependent list is going to be guilt. So also I'm going to go to options and I'm going to click descriptive to make certain that I can get my descriptive statistics from unit 2. And then also I am going to click Cheffe to do my post hoc test. So now I can just go ahead and hit continue, and there you can see that SPSS has calculated several different tables for us. The first one again is the descriptive statistics, and as you can see there that the mean of each of the groups differ. The criminal record has a mean of 8 for a score. Remember, 10 was that they thought she was completely guilty. The clean record people had a mean score of 4, and then those that had no information about guilt or innocence had a mean of 5. So now what we're going to do then is with our analysis of variance is we're going to see whether or not we can take the null hypothesis, which would be that there would be no difference in their output, what their score would be, or the alternative hypothesis, which would be that there is a difference. All right? And so with my ANOVA, you can see that my degrees of freedom here for my between groups difference is 2 because I had 3 groups minus 1. And then my degrees of freedom for within groups is going to be 12, which is 15, the total number, minus the number of groups, which was 3. Well, you'll notice that I have an F value of 4.063, which seems like a pretty large number. If you go back again, because I like to keep using tables, just because I think it helps me remember a little bit more. On page 669 is your cutoff scores for the F distribution table. And across the top, our number of degrees of freedom, numerator degrees of freedom, talks about between groups here. And then the denominator degrees of freedom talks about within groups. So what I want to do is find that cutoff F value with that particular information at the 0.05 alpha level. So I'm going to go down to my denominators with the degrees of freedom of 12, and then I'm going to go across to where my degrees of freedom for my numerator between groups was 2. And then I have to go to the middle value there because I'm at the 0.05 alpha level. I can see that that F cutoff value is 3.89. Well, I can see here that 4.063 is greater than 3.89, so that tells me it's going to be in the critical region. And because of that, because it's in the critical region, I'm going to reject the null hypothesis and say that there is a difference between the groups and how they scored there. But now that we've got that there is a difference, the population means we're not all the same. I can tell that from here, but it doesn't tell me which population means differ from which. So what I'm going to do here is I'm going to use a post hoc comparison, and post hoc means after the fact, and so that's why we're looking at this after the fact. Well, you can see in my post hoc table that I have here, I'm going to go ahead and I did a Chaffee test. So what I'm going to do here is look at my significance, and remember that my alpha level was 0.05, and so if I look at my significance for criminal record versus clean record, I have a significance of 0.054. A criminal record with no information has a significance level of 0.164, and then we have one last one to look at, which is the clean record group and the criminal record. No, excuse me. Yeah, the clean record and the no information group, excuse me, right here, I see it. And you can see that the significance level there is 0.795. So what that tells us for all of those is that the difference is not statistically significant, because all of those significance values were greater than my alpha value of 0.05. So overall, none of the 3 Chaffee post hoc comparisons was significantly statistically significant. I apologize that I've got that wrong in the back there. Statistically significant. Well, hopefully this will help you make it through your Unit 8 discussion.